This call is now being recorded.
Okay, as I was explaining, now over here in further pure maths, I will just go over the contents first. For example, complex number, imaginary numbers, we did not have any idea regarding this because we never worked with this type of numbers before. Okay, this is your first time looking over these numbers, but then again, this is not that much tricky, to be honest, quite easy. And for chapter 2, roots of quadratic equation, alpha beta calculation. Iman, did you have pure maths, further pure maths in IGCSE?
No, teacher. We only did Maths A.
Let's see. Okay, no problem in that case. We can obviously understand this, but this chapter 2 was actually taught for further pure maths in IGCSEs. Okay, so this is no, in that case it will be new for you again. Sorry. And then again, numerical solutions of equation. This is also new. And coordinate geometry, parametric equations, center of parabola. These equations, this kind of equations again come in your P3 calculations. P3, no, sorry, not P3, P4 working, okay? So chapter 4 might be new for you, but it will be repeated again in further in our pure maths classes also. We will do parametric equations again in chapter 4, maybe chapter 3, P4 in that case, okay? And matrices, we did matrix 2 into 2 matrix, 3 into 3 matrix in our IGCSE Maths A, right? It is quite similar to that. Only problem is that now you have to do some kind of proof functions, prove maths with matrix equations, okay? That is the only tricky part. Other than that, not that much difficult. And again, transformation using matrices, we did these things in Maths A, right? In IGCSEs. Our entire triangle got transformed, translated, reflected, right? We saw these things, scale factor, enlargement. We saw these things in IGCSE Maths A. So basically for you, 5 and 6 would be a little bit easier, not that much easier like the ones we saw in IGCSE Maths A, but overall the pattern will be similar over here. And lastly, you have series. We did series, no, we did not did series in IGCSE Maths A, but we will do series in Pure Maths 2 again. And again over here, this series is a little bit different than what we see in Pure Maths 2, but they have a little thin connection in between them. Okay, for the Pure Maths 1 series and Pure Maths 2 series have a little bit connections in between them, but not entirely similar. This is quite different than what we will see in series calculations for Pure Maths 2. And again, lastly, prove by induction and all these things. It would actually appear a little tricky, but if you practice it a lot, this is actually the easiest topic over here. Or not exactly, even if it's not the easiest, this is actually the fun topic over here. Induction, proof by induction is the very interesting maths, to be honest. Like other than this, for example, parametrics, matrix calculations, the questions are not that much interesting. Chapter 8 of proof equation is actually very much interesting, and it will actually contain all the content that you have studied in the first 8 chapters. They will be proved by induction using series, using matrices, using parametric equations, and using complex numbers. So basically, whatever you have studied till now, till chapter 7, till chapter 8, everything will be used in the form of proved by induction in chapter 8. Well, I think that's why it is most interesting, because everything we learn in FP1 will be asked in one question under this topic. And another thing, like in our M1, M2 classes, I've already stated that we will selectively finish few topics first, and later on we'll finish the rest of the topic. For further pure maths, there's no need of that. We will not break down the serial contents, serial over here in the book. Okay, we'll start from 1, we'll go on with the same content direction, 1, 2, 3, 4, 5, 6, 7, like this. Now, is there any questions regarding this, contents over here?
No, teacher.
Okay, then we're going to move forward to chapter 1 today. Chapter 1 was for complex number. Okay, now I'll explain complex number a little bit later, but in our pure maths class 1 today, when I was asking you to factorize, this equation. If you remember, when I asked you to factorize 2x square plus 4x plus 10, can now you tell me that what will be the roots of this equation? Use your calculator and find out the value. X1 and x2.
X1 is minus 1 plus 2i. And x2 is minus 1 minus 2i. Sorry, x2. Yeah, x2 is minus 1 minus 2i.
Okay, and I'm sorry, there was some internet issues in my place. As I was explaining that for this kind of situation, whenever you try to factorize an equation like this and you get the two roots as I and I, then we consider that, okay, I'm not able to factorize this, and now I'll consider this is a complex or imaginary number. Now understand that complex and imaginary are not same. Okay. Complex number means whenever it has I in that case. For example, why does this equation does not have any solution? Because when we were maybe using the formula, that other formula method of this quadratic equations were minus b plus minus root over b square minus 4ac is equal under a root divided by 2a, right? Whenever this entire thing b square minus 4ac, the entire portion turns out to be negative, there only we do not get any solution. There only we get an I over here. So first thing to understand in this case is that whenever you get a negative number under a square, okay? So negative number under the square, then what happens whenever you get a negative number under the square? The value turns out to be as imaginary. Okay, this is not complex yet, this is imaginary. So then we write that as I. And what is exactly I? For example, there's no possible number who can give you root 1, right? Root minus 1. There's no possible number who can give you root minus 1. So there's no number who you can make a square to get a final value as root minus 1. So that's why the imaginary number is known as
Teacher,
yes,
what
no,
does under the square mean?
under the square root. Sorry, wait, I didn't wrote that yet. It was supposed to be under the square root.
Oh, okay.
Right? Negative number under a square would always be positive, right? That is possible, to be honest, right? What do you get after you do minus 2 root minus 2 square? You get 4, right? There's no problem with that. Problem arrives when you're working with root with a minus 2, right? Then you cannot get any value out of it, because now inside a square root, you get a negative value. So with this situation, for this kind of situations, whenever you get anything negative, you consider that as imaginary. Okay, imaginary number is actually this one, minus 1 root. square root, minus 1 square root. So that is your imaginary number. An imaginary number will always be given in the form of, like they will always be given in this format. The format is BI, where I can understand that B could be any number from the real number set. Okay, only I indicates that value for I is root 1, say root negative of 1, and B could be any positive real numbers or negative real numbers, anything. It could be a set of any real numbers, but that is your format for imaginary number. Okay, and then again, what is the format for complex number? Complex number is again like this. Complex number is a combination of imaginary and normal number. Okay, complex number is A plus B I, where obviously I is root 1, root negative 1, and A and B both are a set of real numbers. Right? This indicates that the A and B both could be any numbers from the real number set, but I will always have to be that negative 1 root. Is this clear? Any question regarding imaginary and complex so far?
No, teacher.
Okay, then we will move on to your maths now. This is it we need to know so far. 1 minute. This is 1B. So we only have 7 questions here. Okay, so let's start solving I, J, this and this and this. Okay, so let's start solving from question 1. It says that write each of the following in the form BI, where B is a real number. Okay, and you cannot use calculators for this exercise. So we have to, I mean, over here, do not use calculator for this exercise means that you have to show all the workings over here, right? Because in your exam paper, how will they know that if you're using the calculator or not? When you can use a calculator, you just have to show all the workings. That is what they actually want to say. Also, how was your P1 exam today, Sorry, physics 1. Physics unit 1 exam.
It wasn't bad, but I did find some questions difficult.
You were supposed to find some questions difficult. Which questions? The last questions from the paper, right?
Yeah, 8
Theoretic
and 9.
8, right? Yeah. No problem. This was just a test, okay? I mean, I'll obviously explain the questions later after he comes back and he sits for the exam.
Okay, teacher.
Okay. Now in this case, for this root 200 negative, I can, to be honest, break down 200 under a root, right? And that will give me what? 100 something, right? For example, root over 200 actually gives you something. I think 10 root 2 or something. Yeah, it gives you 10 root 2. But problem is if we have a negative in front now, we cannot use that. So what I'll have to do is that I'll break down this 200, multiply it with 1 minus 1 and restore the same value, right? This also still means the same value. And again, after this, I will just separately write 200 and multiply this separately with minus 1. Only over here for this root 200, how much I'm going to get? This time the value turns out to be 10 root 2. Okay, so we get 10 root 2. And what is negative 1 root? It is I, right? So you get 10 root 2 I. And that is your imaginary number. But in this kind of situations, they always write I right in front of that root. This is how it should be written. 10 I root 2. Right? Is there any confusion regarding question I?
Why is I written in front of 10?
In front of root 2.
Oh, sorry, in front of root 2. So it's
In
supposed
front
to
of
be
root
like
2.
that?
Yeah, it's always supposed to be right there because root 2 is considered another constant, right? So we write in front of root 2 the value for your imaginary number I.
Okay.
Then after this, you have 147. Similar working also has to be done over here. Right, for J again, what you have to do is that I know 147 will be multiplied with minus 1 under our root. and which means this will be, what is root 147? You can again use a calculator over here, right? Which is 7 root 3 multiplied with minus 1 root, again 7 root 3i, or it should be written as 7i root 3. Any questions from this so far?
No, teacher.
Yeah, and quite easy, right? Initially, the questions are quite easy. Now, in this case, the next questions, what happens? We are actually, these are now complex numbers, right? They are saying that they need to give you answer in the simplest form, a plus bi, where a and b are integer numbers. So they're basically asking you to, like, add the complex numbers over here. Okay, in question I again, what happens? You have minus 2 minus 7i. Understand that 2 over here is a normal number. 7 is imaginary, like 7 is a part of that imaginary number, right? And then again, 1 and 3i minus minus, it will be 12 minus I. So what happens is that you cannot add the imaginary numbers coefficients with the normal numbers. You have to take all the normal number togethers and the imaginary numbers together. So you have minus 2 plus 1 and plus 12. And then again after that you have minus 7 plus 1 minus 1i. Right? Oh, maybe made a mistake. It's supposed to be 3 also. Minus 7 plus 3 minus I minus 1 I. And from there you get 13. 13 minus 2 is 11. So 11, this is minus 11 plus 3 is again what? 8 in that case, right? Yeah, 8. Wait, is it 8? That is 8. 8 minus 3 is 5. Sorry, this is supposed to be minus 5i in this case. 11 minus 5i. Right, and that is how the complex number over here is going to look, 11 minus 5i. From the next question, if you move on to J, there also you have to do the same working. I can only add 18, 15, and 3 together. But then again, in front of 18 and 3, sorry, 15 and 3, you have a minus. So basically, you get 18 minus 15 minus 3. And if you add this, you're going to get 5 plus 2, right? Minus and minus is going to make that plus 2 minus 7i. Finally, you get 18 minus 15 minus 3 is going to give you 0. This is your 0. And other than that, you have 5 plus 2 minus 7. Over here, sorry, 5 plus 2 minus 7. Over here also you got 0, right? Because 5 plus 3 is 7. 7 minus 7 is 0 entirely. So you get 0 plus 0i. Doesn't matter over here, the value of your I was negative 1. Whatever you multiply with 0, you're going to get the final answer is 0, right? So in this case, for question J, the final answer was entirely 0. Is there any problem from this question to I and J, Hemant?
No, teacher.
Okay, I'll give you the classwork a little bit later, but then again, you have to simplify these functions again, right? These are now, the questions are given in what format? In fractions format. Question 3, right? Then again, over here for question G, what you can do is that 9, you can separately write that 9 is divided with, what is this? 3, and then 11 is divided with 3, right? So in that case, you get 9 divided by 3 plus 11 divided by 3i, which tends to give you 3 plus 11 over 3i, right? And that is it. Over here, you cannot do anything more than that. After that, again, For 8 and 4, for question 8, now you can do LCM. If you do the LCM for 8 and 4, the LCM would be 4. So you get 4 under the denominator. And in the numerator, you have 8 plus 3i. And on the next one, it will be 14 plus 4i, right? Because it gets multiplied with 2, right? So you have minus 14 minus 2 minus minus, it's going to be positive 4i. And from there again, if you add the constants together, minus 8 plus 14 is going to leave you with what? 4, 5, 6, positive 6. Oh, wait, no. This is minus 18. So minus 14 and minus 8. This is minus 22. Sorry. And then again, positive 7 I divided by 4. Further, you just have to write 22 over 4, 7 over 4 I think you can divide 22 over 4. That turns out to be 11 over 2. So you have minus 11 over 2 plus 7 over 4i. Is there any question regarding this so far?
No, teacher.
Okay, if there is no question, then we can give you a classwork now. Try to solve question D and this D. Okay, question 2D and 3D is your classwork. Try to finish this and send me a working in WhatsApp.
Okay, teacher.
Okay, I think you have sent me a file. 1 minute. 1 by 2 plus 5 by 2 is 3. And 1 by 3, 5 by 3 is 2. Okay. And then you have to multiply this 20, 20 plus 4 is 24. This is 15, 15 plus, so minus 8 is 7. Yeah, this is it. These are correct, right? Okay, then we will move forward. In question 4, so you have to do rationalization. Now you can see in the denominator, they have fractions, right? 1 plus root 3 is a fraction. So for this situations, you have to do rationalization again. Okay, so let's do question 4B in that case. For further maths and M2 and D1, we will actually try to do most of the classes from the exercise in class. And later on, I'll give you a homework as a worksheet. Okay, so like the one in D1 classes we gave, similar for F1, FP1, and M2 also we will focus on that. Okay, so that's why I'll be trying to I will try to finish like most of the maths in class, and in our worksheets, as in form of worksheets, we will solve it. We'll give that as homework. Now in this rationalization, what happens is you have a denominator in the root. So we are going to multiply 1 minus root 3 and then again divide with 1 minus root 3. So in the numerator, what do we have? 2 with 1 minus root 3 is going to be 2 minus 2 root 3. 6 with that would be 6 multiplied with 1, which is 6i. And then again 6 is positive 6i root 3. Right? After that, you have this is it. Sorry, we have after this is it. In the denominator, you're going to get 1 minus 3. That's going to be minus 2 in the denominator. And in the numerator, you got 2 minus 2 root 3. Unfortunately, you cannot add the 2 minus 2 root 3 over here, right? So you have to write 2 minus 2 root 3. This is like a one pair of the constant number. And after that, you have minus 6 plus 6 root 3. So I just write plus 6 root 3 minus 6 root 3. So it's minus 6. So if you from there, if you take 6 common, it will be 6i. Wait, maybe I can also take that I common, right? No, I cannot. I'll just write it as this one, 6i root 3 plus, so minus 6i. And everything was divided by minus 2. I can, like separately write the constant and the i's together. So you have in the constant, if you take 2 common, you have 2, 1 minus 1 root 3 divided by minus 2. And then again, in between them, you have a positive number. So then again, you can write 6 root 3 minus 6 divided by minus 2i. From there, again, I can consider taking the 6 as a common number, which is going to be root 3 minus 1. I can cancel out this 2 and 2 together. This 2 and 2 together leaves you with 3 in the numerator. So you have 1 minus 1 root 3 and plus 3 root 3 minus 1. This is going to be an I over here. Or I can break this down again. 1 minus 1 root 3 and 3 root 3 minus 3i. This is how you're supposed to do rationalization for complex numbers. Is this clear, Imad?
Yes, teacher.
Okay, then we'll quickly move on to the next questions. Exactly what happens over here, they're saying that Z1 is this value, Z2 is this value, and Z3 is in, so Z2 minus Z1 is this value, right? They have to, like, you have to find out the value for the alphabets A and B. Okay, in that case, A plus 9i and minus 3 plus bi. You just have to subtract them and then make them equals to 7 plus 2i. It's quite easy. 1 minute. Let's see question 7. What is that? Z1, Z2 in the form of this. Yes, 6 and 7 are quite similar. And in 8, what do we have? Z, W, and these are in terms of A, B, A minus B. Is a real value, is always imaginary. Okay. 8 will be a little bit tricky. I'll do question 7, 6, and then we'll jump to 8, okay? Because 6 and 7 are quite similar. I'm not going to do the same process in 7 again. Do you think so far for the pure maths is quite tricky?
Yeah.
Okay, I think that's because we are doing, I mean, I was actually thinking we could also move to 1B. Do you think it's quite a little bit pressure so far?
So far in this class, so far it's so good. It's no problem.
Okay,
But I've heard from many students that it gets very hard.
to be honest, if you're comparing this with A-levels chemistry, then further pure maths is nothing in front of chemistry. Do you have A-levels chemistry, by the way?
Yeah, I'm taking that as well.
Okay, then all the best. because like for me actually I hated chemistry. I mean, I tried a lot in ACE chemistry. ACE chemistry is, to be honest, very good. You will get easily marks in unit 1, unit 3. Unit 2 is a little bit lengthy because you have organics there. For me, I'm really bad in, like, memorizing the formulas, benzene and everything. I think in today, yeah, in unit 2, you will see that trans structure and cis structure. At this point, I don't understand that how to actually identify which particular organic material is under the trans arrangement and is under the cis arrangement. And on top of that, they're going to introduce rings, benzene rings, and they'll ask you that, how do you make ibuprofen, and what is the formula for ibuprofen? My entire thinking was that why do I need to know ibuprofen? I just want to take A levels chemistry for my university admission. But they will, make you half pharmacist after A levels chemistry.
Oh, I see.
But
So
then
you found
yeah,
chemistry the hardest then?
yes, I found for me chemistry was the hardest thing. It is actually chemistry unit 5, which was extremely difficult for me to memorize. But then again, this is not the case for everyone, to be honest. Are you good in memorizing, by the way?
Memorizing, I don't think so.
Okay, then I would suggest, there's actually one book you should follow for chemistry. That was is George Facer. I mean, George Facer is present for AS and A2. Like in physics, we follow order mostly, right? Because, I mean, if you want to read a book, do not read the book for the Pearson's Edexcel Student Book 1. That is a waste of time. But if you want to read a book for physics, you should read the order book. Okay. For biology, yeah, for biology also the same order book. And for maths, to be honest, there's no book. You have to practice the, given question from Edexcel and practice the question paper under a chapter wise process. Okay, so there's no actually book available for the chapter wise process. So that's why we make the chapter wise worksheets for you after we're done with one chapter.
Uh-huh.
So we will do that for both masses, normal maths and further maths. And for chemistry, George Pacer is extremely helpful. All the question papers they're going to ask you, okay, everything is written on George Pacer. And again, the chapter end questions from the George Pacer is also very helpful. I'll give you the link for that file, okay? You can see that.
Okay. So, can you also send the link for the physics book?
The physics is already uploaded in our classroom, maybe for water.
Oh, the one you were talking about right now?
Right, that is already uploaded in our classroom.
Okay.
And for maths, we do not have anything. But for physics or chemistry, we have this book, George Facer. I have the file, I'll send it to you.
Okay.
Now, in this case, what happens? I know that the simple numbers can be added together and the complex number will be added together, right? So if you have, I'll first remove the brackets. You have a plus 9i plus 3 minus bi is equals to 7 plus 2i, right? From there again, you have a plus 3, that is a simple numbers, and then 9 minus b is an imaginary number, is equal to 7 plus 2y. In this case, after this point, what this is indicates? It indicates that left hand side is equals to right hand side. That means this portion is equals to 7 and this portion is equals to 2. And now I just have to start comparing over here. That is it. So I start comparing and we will write a plus 3 equals to 7, which turns out to give you a is equals to 7 minus 3. That's 4. And then again, 9 minus b is 2, which turns out to be b is equals to 9 minus 2 is again 7. Right? So this is how you can compare and find out the values of your alphabets. Any problems so far?
No, teacher.
Okay. Then we will move on to question 8. In question 8, what happens? Again, they have these two values, and now they're saying that x plus y, so x plus w is a real number where x minus w and z minus w is an imaginary number. If you add them together, what happens over here is that a plus bi gets added with a minus bi, which means that bi cancels out and you're left with 2a, right? All the imaginary portion of this complex number got cancelled out. So obviously you got a real number 2a, right? Because a was a real number, a is a set of real numbers. So this is 2a is always already a real number. And when you're subtracting them, you get a plus bi minus a plus bi. Now a gets cancelled out and you have 2bi, right? So this time you have imaginary numbers left and no, this is not a complex number because in complex number, you must have one constant, one real number and one imaginary number, right? Over here, you only have one imaginary number and no real numbers. That's why 2bi is just an imaginary number. Is there any question regarding 1a so far?
No, teacher.
Okay, then I still want to explain a few maths from question 1b. Okay, I will not explain a lot of this math from this exercise. Just one maths from here. Okay, and then we will stop. So that I can give you at least some homeworks from there. So it says that solve each of the following equations and write your answers in the form of plus minus pi. So we'll solve this one. 6z square plus 1 is equals to 2z square. Z square. This was question F from 1. Exercise 1b. Right. So now from this case, if you take all the values to the left-hand side, this is how the equation will look. 6z square minus 2z square plus 1, 0. You get 4z square plus 1, 0. Right. From this part, what I can understand, what type of equation is this, Emma?
I'm not sure.
You have an x power, right? That means this is a quadratic equation. But then again, in this quadratic equation, one term is missing, right? The coefficient of x is missing, right? That is it. Otherwise, this is a quadratic equation. So from this part, since the coefficient of x is missing and in general cases, quadratic equation is supposed to look like this. Az square plus bz plus c equals to 0, right? Over here, this term was missing. To be honest, even if this term was missing, the maximum power for this equation was power 2. That means whenever in an equation, the maximum power for your alphabet is 2, it will always be a quadratic equation. Is this clear, Imad?
Yes, teacher.
And how many solutions you're supposed to get from a quadratic equation?
2 solutions.
2 solutions. Okay, so we will keep that in mind and try to extract 2 solutions out of this equation. So you have 4z square equals to minus 1. So you take this minus 1 divided by 4 under our root, right? Now exactly what you have to do is that I have to break down that minus 1 separately from this fraction, right? So we have minus 1 over 4, which can be written as 1 over 4 multiplied with minus 1, everything under our root. And again after this, and also I think you know that whenever something comes out of the root, you always get something as positive and negative, right? For example, root 4 always gives you plus minus 2, right? Over here also doesn't matter what I'm going to get. It will always have that plus minus value in front, right? This is 1 by 4 under a root multiplied with minus 1 root and then again plus minus. Minus 1 root was what? Minus 1 root was I. And 1 by 4 root is actually half. So over here you get plus minus half I. Right, and that was exactly in the form your question asked you to keep your answer. They ask you to keep your answer in the form of plus minus bi. Over here, the value for b is actually half in that case. Is this clear?
Yes, teacher.
Okay. Now, do you think I'm giving you too much pressure till now?
No, it's actually fine.
Okay, then I'll also explain one more maths. Okay. Um, we'll solve this one. Question C. 16 z plus 1 whole square plus 11 equals to 12. Okay, 1 minute. Solve each of the following, and again over here you have to keep your answer in the form of complex numbers this time. Previously in question 1, they asked you to keep your answers in the form of like what? In imaginary number. Now they're asking to keep your answers in the form of complex numbers, right? So for part C now, 16 z plus 1 whole square plus 11 equals to 2. Okay, 1 minute. From there, first thing I have to do is that I'll change the position for 11 from the left hand side to the right hand side. Where it will be what? 2 minus 11, and you're going to get minus 9 there. So you have 16 z plus 1 whole square minus 9. And then again, after this, you take that position of 16 to the right hand side, you get z plus 1 whole square 9 over 16, and obviously negative. You take the square again to the right hand side. This is under a root, right? I'll keep that x plus 1 to the left hand side, and I will try to break down that 9 over 16 in the form of imaginary number. So 9 plus 16 multiplied with minus 1, everything under a root. This is obviously going to be a plus and minus situation over here. The next line would be 9 by 16 under a root, plus and minus, multiplied with a separate minus 1 root. And after this, 9 by 16 is actually under a root, is going to give you what? 3 over 4, right? So this is plus 3 over 4 under a root, and this was I. Previously, on the left-hand side, you still have another 1 left. So if you take this 1 to the right-hand side, this is how the two roots are supposed to look. Minus 1 plus minus 3 over 4 root I. Right? And this is it for question 2C. Let me know if you have any problem from here.
No problem, teacher.
Okay, then we will move on to the next question. For the next question, you might have to do. Yes, now they're asking you to, this is exactly in a quadratic equations now, right? Now they're asking to solve this quadratic equations. For example, 3 and 4 is exactly similar. 3, 4, 5, 6, they're all similar, to be honest. Let's solve question F, 3F. No, so not F. Let's solve question 4B. Okay, 7z squared, 3z plus 3, minus 3z plus 3. Okay. 7z squared minus 3z plus 3 equals to 0. Now you can solve this equation in two formats. You can use the completing the square format. Also, you can use that formula method. So if you use that completing the square method, then let's see how it works. The completing the square now, capital A is going to be 7, right? Capital B is going to be B by 2A, that was your formula. So minus 3 over 7, so 2, 7, which is 14. So this is going to be like what? 3 over 14. That cannot be broken down because 3 is a prime number. And then again, capital C over here is C minus B square over 4A. 1 minute. Okay. And there the value for C was 3 minus 3 square This is also negative, divided by 4, 7. Right, Imad, can you calculate the value for C over here for me?
It shows 75 over 28.
Okay, 75 over 20. That is answer, no problem. Now, in this case, we are actually going to write this equation in the form of 7 x minus 3 over 14 x squared plus 75 over 28. Right? This is how the completing the square equations look like. And after this, we will move forward. So from this part, we have 7 x 3 over 14 x squared plus 75 over 28 equals to 0. And with time, I will take everything to the right hand side. Finally, this is how it was supposed to look. 75 over 28, right? This entire thing will be divided with another 7. And try to calculate it. How much is this? 75 with 28 and then again divided with 7.
Yeah, it's 75 over 196 minus 75 over 196.
Right. In that case, also we know that if we change that root to the right hand side, everything will be under the root. And if you calculate this, you get, if you simplify this, you're supposed to get 75 over 196. Okay, sorry, made a mistake. This was all the time Z. I was writing X. Okay, now over here, if you simplify this is 75 over 196. I can break this down as 75 over 196 multiplied with minus 1 root. Right? And then again, what do we get? If you do the root calculations for the 75 over 196, you're going to get 5 root 3 over 14. And finally, you can write that, what? This is going to be 3 over 4 plus minus 5 root 3 over 14i, right? And that is your complex, and that is a solution over here. Is there any problem regarding this?
No, teacher.
Okay, now this is one of the formats by which you can solve the quadratic equations. Other format is your formula method. Okay, so we'll see that now. Formula method. And what was your formula method? It was minus b plus minus b square minus 4ac root over divided by 2a. This is your formula method. Over here, I was trying to calculate the value for z, right? So it is going to be what? Minus b. B over here was already negative, minus 3, so it will be 3 plus minus root over 3 square minus 7, sorry, 4, 7, 3 divided by 2, 7, which is going to be 3 plus minus 3 square is 9, and 9 minus 4, 3, 7 is minus 75 again there. So you have under the root minus 75 divided by 14, right? And again, in this case, you have 3, 14. Oh, wait, this was actually 14 all the time, right? Okay. 1 minute. 14, 14. Okay. Now, in this case, again, for this part, root 75 can be broken down as this 3 plus minus root 75 multiplied with root minus 1, which is going to be a complex imaginary number, right? Now, this is again root 75 can also be broken down as 5 root 13 I divided by 14. Finally, you can write this as 3 over 14 plus minus 5 root 13 by 14i. Right? Now you can see it doesn't matter if you're using the computing the squared formula or the what is this formula method, right? At the end, whatever pathway you follow, you're going to get the same answer, right? And that is your solution over here. I mean, for quadratic equations, if you want to solve the quadratic equation in terms of formula method, you can do that also. If you want to solve that in terms of completing the square, you can also do that. It's up to you which formula you want to use over here. Any questions till now, Imad?
No, teacher. Teacher, we can simplify that by canceling the 14, yeah?
No,
Oh,
we
it-
cannot actually,
no, no.
because 5 and 3 are prime numbers, right?
Yeah.
If it was maybe some other numbers, we would be able to do that, simplify that, but we can't do that now.
Okay, teacher.
Okay, then this is it. We are done with the first lecture actually. We, to be honest, completed entire exercise 1A and 1B. In that case, I will not give you an example, any homework from 1A because 1A was entirely easy. Try to complete question 3, 5, and 7 from 1B. Okay, only this question 3, 5, and 7. Also, I did give you one homework from Decision Maths 1, worksheet 1 for D1. Did you complete it that?
No, I didn't complete it yet. Teacher, when is the next D1 class?
On Friday.
Okay, I can complete it before then.
Okay, try to submit your paper by Thursday night so that I can check it and then we can do the solutions on Friday, okay?
Okay, teacher.
Also, there was another homework for M1. What happened to that?
M1, I did it and I submitted.
You submitted in the classroom.
Yeah.
1 minute. I didn't got any notification about your copy.
It's homework 1, yeah, the one from the textbook questions.
Oh, no, that was one of the homeworks. Other homework was your worksheet 1.
Oh, that one, yeah, I still didn't do it.
Mm. Oh, in that worksheet 1, they you will see actually there are like, wait, sorry. For homework 1 also, I actually didn't got your copy, Ahmad. Can you please resend it to me?
On Google Classroom or WhatsApp?
Try to submit your paper in Google Classroom, but if it doesn't get submitted, then send it to me in my WhatsApp, okay?
Okay, teacher.
Okay, in that case, for that worksheet 1 from M1, you actually have to solve out of 18 questions, you actually have to solve 10 questions, okay? You'll also see in the same folder that I have some, like, solved few questions from the worksheet again. For worksheet 1, you will see that in the class slides section, we have uploaded the worksheet 1, worksheet 2 solutions, okay? So other than the questions we solved in class, you have to solve the rest of the questions which are not solved in the class.
Okay, teacher.
Okay, then this is going to be homework from FP1. Only try to solve these 3 questions before next class, which will be on again Tuesday. Okay.
Okay. Teacher, I open Google Classroom right now. It
Mhm.
shows that I submitted. It's attached also, the document. It's M1 homework 1, yeah?
Yeah, it's M1 homework 1 under the chapter 2 section, but I can only see that Asri is submitted the file. Other than that, your one says it's assigned but empty. Can you
Oh, that homework 1. Is it the chapter review 2 full?
yeah, chapter review 2 full, that one.
Yeah, no, I didn't do that. I meant the other one.
Which one? Oh, wait, let me just turn on my screen and then you can see.
The latest one you uploaded.
Oh, chapter 4. From chapter 4 in that case you're
Yeah.
talking about, right?
Yeah.
Oh no. This one. This is actually supposed to be under chapter 4, sorry. Okay, you uploaded. I got a notification for this one, but you still have to submit this ones. Homework 1 from chapter review, worksheet 1 from chapter review.
Okay, teacher.
Okay, and that too again by this week Thursday, because on Friday, we will try to solve maybe a few questions, problems from this, because I want to take an exam after chapter 2.
Okay, teacher.
Okay, then thank you for joining the class, Imad. I'll start the class over here. Bye bye.
Okay, thank you, teacher.